Hello, my name is Akshat and today I will be showing you a tutorial of how to build a text to SQL agent. Okay, but before we start with it, we need to understand what we are making and why we are making. Okay, first let's go with the heading. Building a text to SQL agent. We are aware of what is SQL is. It is a way of talking to any structured database like an SQL database, a Postgres database, anyone. Now, agents are just autonomous software programs that are capable of thinking like humans, or they come close at least to thinking like humans. It can be an intelligent Python function and RL environment, anything. Okay. Now, why we need this? Okay, suppose you are in a healthcare setting and you are an assistant and you are tasked with solving users' queries all the time. Sometimes you have to, clank your keyboards in a database to answer certain queries. Now, you may be lucky enough to have a web UI, like a simple dashboard which is capable of drop down and selecting like okay, in ward A there are these number of males, in ward B there are these number of sick people, with pre-built SQL queries coded on the backend. Okay, so either way you have to go through the manual effort of doing this, or you are a data analyst working with a hospital and you need complex queries, you need complex information, and you may make mistakes with the query or be generally frustrated. Okay, so we are aware to solve these problems we need a text to SQL agent. In its core, it only takes a prompt and it converts it into a structured, syntactically correct SQL query. Okay, it should not hallucinate. We will come on this later. Okay, so okay, we have a prompt. Hello, how are you? Count the number of males in the hospital. Okay, this is the prompt which the user gives us. Now the output should be hello, I am fine. Here is the query, select count star. This is the query we are talking about, and this is the output of this part. Hello, how are you? Okay, this is the query, and this query ran and it gave us a result of having 501 males. So it said based on the execution result, it looks there are 501 males. So based on the output of the SQL query, it assisted the originally asked question. Okay, it works like an RAG system, but instead of doing embeddings and retrieving and pasting them in the prompt, we are using SQL queries to directly have the results and to better ground our responses. Okay, so in essence, what we are doing is we are answering natural language questions with the help of querying the database, and with the help of the database query the result we got, and the natural language question we are answering the user results, or just saying whatever. Okay, so how would we go about it? The basic and the naive flow would be, we have a prompt, like we had a prompt here. Okay, we tell the LLM that generate an SQL query for the given prompt. The LLM would generate a query. Okay, you can structure the response too, and you will execute that query and you will give the output. Now there are some structural problems with it. There are many structural problems with it, and it is perhaps the most simplest way you can do it, but not the recommended way, obviously. Okay, so the first and the foremost problem is the LLM would likely hallucinate. In this case, we said count the number of males in the hospital. Okay, the LLM could simply say select count star from hospital. Okay, now hospital is not a table. The only three tables we have is patient table, admission table, and medication table. So you need to somehow encode what database we are using, what tables we have, what is the schema of those relevant tables. Okay, so also to explain what are tables and schemas. A table, you probably know what a table is. Okay, schemas are how the tables are defined. You can say the data about how the table is made, what keys they have, what links they have, what are the constraints, what are the data types they can store. Okay, these are the schemas, like the blueprint of a table. Metadata will come on this later. Okay, you might say, okay, Akshat, I will probably paste the information of the table like the schemas of all three tables in the prompt. This way the LLM would likely not hallucinate because it knows now that the hospital table doesn't exist, so it will probably select the admission table, and I would likely say yes, that is a very good approach. Well, the main problem is, what if there are 30 tables here? We have a patient table, we have an admission table, we have a medication table, we have a appointment table, any table. Okay, we have 30 tables, and this is very common when we are talking about large organizations. Okay, then pasting the schemas of these 30 tables into the prompt of the LLM would likely inflate your token cost, will likely make your agentic workflow slow also. Okay, So that is a approach, but not a optimal one, obviously. We somehow need to select only the relevant table, and that is the intuition of what the next approach we will be discussing. Okay, like, okay, we have this admission, okay, but if the query is about count the number of males in the hospital, we have no use of the medication table. Including its schema in the prompt is simply a waste of compute, a time, and would likely also interfere with your model if your model is weak. Also, to clarify, one important thing, we will not be using any API, and by API I mean OpenAI API, because it is not free anymore. It used to be in 2023, but we will be using open source models, like Ulama interface gives us a choice to download many open source models. I will clarify what open source model will be in, but just a clarity thought. Okay, so in the next approach we will discuss how to encode the information of the tables. Okay, this was a naive approach but we discussed. So in the next approach we will likely discuss what the optimal approach should be to encode the information of the tables. Okay. Okay, so we previously discussed the very naive approach of what we are doing. So we concluded with we will include all the tables information, and we concluded with that it would increase your token cost, latency, how much time your model is taking to respond, and it would also slow down your machine, and that is equivalent to latency, but whatever. Okay, so the better flow would be to only encode the relevant table info only, and with relevant the first thing that comes to our mind is RAG, embedding models, similarity search. Okay, so we know that we need the relevant table info only in the prompt that we are giving to the LLM. So how would that approach pan out? We will discuss. Okay, so let's start with the very basics. We had a database, we had a table, we had their schemas of what they represent. Okay, and we pass these individual schemas to the embedding model. This is important. Now, what an embedding model is, an embedding model simply encodes whatever information you have in the form of numbers. Like these are numbers like 7, 8, 9, 2, 5. They are basically float numbers, but whatever. 7, 8, 9, 5, 10, 15, anything. So these embeddings represent information. Okay, and in a more abstract terms, they are points in a vector space, an ND vector space. Some points here, like let's say x, y, z axis, some point here, okay, some point here. And if we have a user query like something pointing here, we measure the user query's similarity with all of these. Okay, there are multiple methods, like we can use an L2 distance method, what we call an Euclidean distance, or we could simply use a dot product, but that is beyond the scope of what we are discussing. So a simple RAG tutorial will tell you this. Okay, so we know how similarity search is done. Okay, so we have the embeddings of all the schemas we want to represent. Also we have a query, what I said, whatever the query, and the embedding of this query too. Okay, like in the previous board wrap also I told you. Okay, so we compare all of these embeddings with this embedding. Okay, and we have an hyperparameter which you can tune, which is called top k is equal to. Now top k, what top k does is it only retrieves the top k number of relevant, embedding models. Like embedding model is a wrong term. Top relevant embeddings, more likely the top relevant schemas. Like from these three tables, if I set top k equal to 2, and my query was how many patients are in ICU, the top tables will be patient and admission table, not a medication table. Okay. Okay. So we have to do similarity search of these three. Similarity search, and we get top k embeddings. there are top K embeddings, or more likely schemas. Like the embeddings can be decoded, so we can say the top K schemas. Okay, so we will pass these top K schemas into the prompt we were discussing. The first approach, like we told, the prompt schema info, relevant schema info, pass it to the LLM, generate a query, execute it, and give an output. Okay, so this approach is fine. It will not likely hallucinate, but there are some problems with this approach too. First of all, you have to select a threshold. Okay. In some cases, selecting, at least this was my thought, in some cases even the top K embeddings which you have selected may not be relevant. For example, for a simple query like how many police officers retired, okay, now this is a police database question and we are talking about a healthcare database. Okay, the queries will match. Okay, the relevant scores will be generated, and if we are talking about cosine similarity, the embeddings might be generated with a score of the cosine similarity score 0.1, 0.2, 0.3, where 0 means less similar and 1 means most similar. Okay, now these are nothing but similar, but we still will select the top two, patient table and admission table info and encode it into the prompt, which will unnecessarily will not do something. To be precise, we will come on this, because this query cannot be answered with what schemas and tables we have. So we need to somehow redirect, okay, the first query before passing it to the embedding model. So that will be our approach number 3, how to deal with the irrelevant queries. Okay, the queries which are probably irrelevant, like how many police officer retired, or what is the weather today in San Francisco, or what is the weather today in Los Angeles or Sonipat or whatever Uttar. Okay, so we need to somehow redirect or retransform these queries. Okay, and that will be the point of our approach number 3. This prompt need to be refined before sending it to the LLM. So that would be the approach number 3, query retrieve repeat step, and we will discuss it in the next board wrap. Okay, so in the previous approach, we closed off with how, with a misreading query, even extracting the relevant table schemas will not be enough. Okay, for example, take this query: hello, what is the weather today? Can you help me with something? I live in India. What are the total number of patients in the hospital? The relevant thing which we can attend to is this only. Okay, this part, and it can be any part, like total nonsense, gibberish, whatever. This will confuse the model. If the model is very small, or we are probably using open source models too, or it would probably add to the token count too. Okay. This will confuse the model, and if this 2 lines are 20 lines or 25, 30 lines, the 25 lines will probably shadow these 2 lines. Okay, so we need to somehow extract this information, the relevant information on what we want to do with the database, and attend to this natural language query separately. That is our final approach, but my approach will be to how to transform this query before processing, like how we pre-process the data in data analysis too. We standardize it, we scale it, we extract the relevant information, we feature select, we drop the relevant irrelevant columns. Okay, so our previous approach was prompt. Okay. We encode the schemas of the relevant tables, we pass it to the LLM generates a query, we execute that query, and we give an output. Okay, now this prompt is this. Okay, we need to somehow clean it. So what we can probably do is, and this approach is called the R3 approach, the query transformation approach. Microsoft researchers wrote a paper on it. When I show you the implementation, this will become more clear. It's just a prompt technique, nothing too sophisticated. Okay, so what we need to do is we somehow need to refine this prompt, enhance this prompt, extract only the relevant things. So it should become something like this. This prompt should probably get converted into this only, or enhanced, like generate SQL query for what are the total number of patients in the hospital, and also tell hello, what is the weather today, can you help me with something. This should be the transformation. Okay, So what we are going to do is, so what we are going to do is, we will pass our initial prompt to a smaller LLM, a much smaller one. We are using this smaller LLM on purpose because using a larger LLM would probably add to our token cost, and refining the prompt is not such a big task. So a smaller LLM like V3 Mini or Quen models will probably suffice, or a Llama 3.2 model. Okay, so we will give a refined prompt to our LLM that extract the most relevant parts, relevant SQL parts, or the prompt will be very defined. I will show in the implementation. It's a multi-line prompt, okay, with few short examples. Okay, now what do I mean by few shorts? It when we prompt an LLM, we need to show it some examples. This is a proven strategy that increases the model's likelihood of giving the response you like. Okay, so we give it to the smaller LLM, and the smaller LLM returns a refined prompt. Okay, the refined prompt is then passed to the LLM, then the query is generated, and then execution. Also with the refined prompt, we also pass in relevant schema information, which I told earlier. Okay, it's the same thing, only this step is added. This is called query reconstruction or transformation. Okay, we have a prompt, we transform its query, enhance the query, and then we pass it to the LLMs, refined with the relevant schema information, which we extracted through embeddings, the similarity search which I have demonstrated in the previous slide also. Okay, the relevant schemas are then sent to the LLMs. Now this will probably enhance the performance, because instead of the unnecessary prompt plus relevant schema information, we are using a refined prompt plus relevant schema information. Now the trade-off is this will increase latency of your application, but if we are using a very smaller LLM, it will be minimal, or we are using an open source one, it would not even cost us a penny. Okay, so this is the approach number 3. We transform the query before sending it to the LLM. Okay, now we talked about all the pre-processing stuff. Now how does this LLM generate a query, and what if it makes some mistakes? We will discuss in the next approach. Okay, so in the previous approach we discussed how enhancing the prompt results in better accuracy. So this is just an overall workflow, but we discussed until now is nothing new. Input prompt, we reconstruct the query, we get an enhanced prompt. Okay, then we extract relevant schemas using embeddings. Okay, then we pass those relevant schemas to the LLM. We generate a node, brain it is called. Okay, so the generate node is the main node which generates the SQL query. Okay, it's the thinking part mostly. Then we extract the query in a sandbox. We run that query. Okay, and we run it in with a read-only permission, no DML allowed. What I mean by DML is data manipulation language, like your insert command. Insert is not allowed, drop is not allowed, delete is not allowed, because what would anyone want with inserting or deleting? These things should be better handled by the engineer also, only. We could even have a human in the loop here. That is beyond the scope of what we are discussing today. Okay, so what more can we do with this? Okay, first of all, let's look at the problems. If we have a prompt like this, and most of the people experimenting with your application will provide something like this, or something, hello, how are you, hello GPT, just your name, just their name, anything. Now, if you run it with a simple workflow which we have established, now this is not an agentic workflow until now, we will add these now also. The query which we reconstructed, what prompt will you enhance? What can you even enhance in a prompt like hello, how are you? Okay. Let's say you enhance something or you made up something. Now this is a very big problem. If you give explicit instructions to your, the LLM which is enhancing your prompt, a smaller LLM, we should add it because we are worried about increasing the latency of our application. Okay. The problem with such an approach would be that we would end up hallucinating, we would end up making things, or the model can simply output hello, how are you, select the tables from the patient column, which is not what we would have wanted. We would simply have wanted to, for a query like hello, how are you, we simply respond like yes, I'm fine. Okay, so when we are enhancing this prompt, we need to address if the prompt is worth processing further in our workflow, or we should simply redirect it directly to our output. Okay, so that is the question we'll have. So what we will do, and this is an important thing also, we will be mostly working with okay, so we mostly will be working with LangChain and LangGraph, and in those things we have an option called with structured output. Okay, with structured output, what we can do is we can force the model to respond in a structured way, like in a JSON format or in specific fields. We specify it using pydantic models, and I will discuss those in the implementation. Okay, so we probably, with the enhanced prompt, we also have a variable called worth query. It will be a bool, obviously. Okay, but this worth query will be indicating is whether the query or whether the prompt, in fact, whether query, it's worth prompt. Okay, whether the prompt that is given to us is worth processing or not. This will be explicitly decided by the LLM which is currently enhancing your prompt. On certain conditions, of course, that is all prompt engineering only. Okay, in case it deems that the prompt we are given is not worthy of processing, like it doesn't have any SQL element or any data selection part, we can simply redirect our flow to output with an LLM in between, obviously. Okay, like simply the prompt, not even the enhanced prompt, the simple input prompt will be passed to the output LLM. Simple, the hello, how are you will be passed as is. There is no need of going through this whole workflow. Okay, if the condition is false, okay, this will be passed directly to the output LLM based on this bool variable. I am erasing this bool variable, but it's taking up some space here. Should probably worth bool. Okay, just a shorthand to not clutter the board. Okay, if it's false, we will pass it, and if it's true, okay, then only we will proceed with our workflow. Okay. Now you might ask, okay, Akshat, this is already getting very complex, but these are the guardrails we should be implementing if we are talking about any SQL application or any production grade application. Okay, so now this workflow would probably be good. It will be a workflow, not an agentic workflow. We need to somehow act according to the environment. Like, what if this query fails? What if the extract query fails? Or what if the query doesn't run? Okay, what if the generate node suddenly fails? So for that, what we are going to do is, and I will show it in the implementation, but just to give a basic idea, if the query we are talking about or the query we should be extracting doesn't run, we retry. This is the loop. Okay, and this retry will only happen for n times. This loop we are forming. Okay, like xn times only. It will only execute n times because otherwise it will be stuck in the loop. Okay. If the query can't be executed, now this is the most important part. Okay. We will run the query in a sandbox. If it hallucinates, we will give our suggestions, and I will come on this later. Okay. Now, we are using a single brain here. Now there is a pattern in agentic AI that is called, it is given in a paper also used by Anthropic for developing their Claude model. It is called reflection pattern. Now, what does this mean? Okay. Now this is the most critical part of what we are building here. What the reflection pattern means is how we reflect on our knowledge. Sometimes we are unable to point out our own flaws. We need someone else to point it, and we also experience this in our lives also. Sometimes the smaller people or the children or the younger people are able to point out flaws which you likely ignore or have a blind eye towards some of those traits. Okay, so we need to reflect. Okay, the query we generated, can it be improved? Is there any errors in it before running it? Okay, because that would save us a lot of trouble. So we need a smaller LLM, and the technical term for it is AI as a judge or LLM as a judge. It's a very popular term. We use an large language model to judge the output of our generation node. Okay, so you might think, okay Akshat, but not in every case we should be doing this. Okay, so for that at least what I have done is, similar to how we attached the work pool variable here, I have a confidence score. Now what confidence score is, confidence ranges from 0 to 1. It can be any value between 0 to 1. Okay, 0.1, 0.2, and with a few short prompts on what is 0.2, what is 0.4, what is 0.6, what prompt should be 0.6. Okay, we can probably encode somehow the information how confident the model is in its prediction. Okay, the model is less confident, we will be reflecting it. And this is getting complex, I should label them. Okay, so this is the first step. Okay, this is the second step. Okay, now the second step has 2 points, true and false. Okay, this is the third step. Okay, this is the fourth step. This is the fifth step. This is the sixth step, and this is the seventh and the final step. Okay. Okay. Okay, so we should have a reflection LLM here. Also, I might add, the reflection LLM will be smaller than the generation node. The generation node will be the most powerful model which we can load. At least in my case, I have an NVIDIA GPU which has 8 GB of virtual RAM. So the most I can load without straining my CPU was a Llama 3.1 model. Then I switched to Qwen 2.5 coder, but the strongest model will be here and will be loaded in the GPU if you have any. If you have a CPU, that's fine also. Llama handles it, but the inference speed will probably be low. Okay, we have a reflection LLM, but the reflection LLM is tasked with to probably criticize it, be a judge, like how people judge in real time. And a famous analogy which I like to remember it by is, it is easier to judge than to implement. Okay, you can have a judge as a slower model, but for a generation you need to have a stronger model, like the society also does. Okay, so this workflow will only be triggered if the confidence score we just mentioned is lower than a particular threshold. The confidence is less than threshold, and this Threshold can be anything like 0.5, 0.6. If a confidence of our model is less than a particular threshold, we send it to the reflection LLM for corrections. And the reflection LLM has a prompt. It is a critic prompt. Okay. It will only criticize. Okay. Okay. So it will criticize and probably suggest improvements, or if there are any errors, it will probably send a suggestion. Now this is the important part. Suggestion. It will run n times, like we said, at least n times. This is the max retries. Okay. How many times will our system retry to improve a prompt? Okay. After the n retries happen, or a confidence threshold is greater than threshold, we will probably move to extract query. Okay. So the suggestions will be incorporated in the prompt. Okay. Suggestion plus prompt. So the next time the generation node generates something, it probably has some input on what it got wrong. Okay. And it will probably generate a very good query. So I think okay. So this is the overall workflow of what we will be doing in the implementation side. I just wanted to share the architecture. Now the most important part. What should be the architectural choices? Now this workflow you can design it anyway too. You could not have a reflection node, or you could not have a run query, and that is the beauty of the generative AI. You can do anything. In LangGraph, this is very possible. These things are called nodes. These things are called edges. These are the conditions attached to edges. LangGraph is just a directed graph, an acyclic or a cyclic directed graph. Okay. So you can design it anyway. Also, I have told you some architectural choices. The model which we'll be using to enhance a prompt will be weak. The reflection prompt will be slightly less weak than this. This will be our strongest model, and we will also use a slightly weaker model here. So at least what I chose was, at least at first, I used in generate node GPT OSS model here. GPT OSS. It's a 20 billion open source parameter model for the generation node. For the reflection node, I used a V3 mini. Okay. Then I switched to Qwen 2.5. Okay. Also, I should switch to Qwen 2.5 here. Qwen 2.5, 7 billion. Okay. Then the V3 mini model. Okay. And in this output also, I think I used a V3 model. Okay. Same with the NAND prompt. I mostly did all the work with the V3 model only for all these weaker models. You can of course use a slightly weaker model here, but I was just short of time, so I made this. Okay, and now there are some things also I wanted. Okay, so this is how we know, and we could probably visualize it in Langsmith also. Langsmith. I will talk about this when we discuss the implementation. The implementation will make this much more clearer. So this is at least the workflow, the architectural design, the architectural choices, how we should think for a simple system as generating a SQL agent. We should be probably thinking in steps. And these can be improved, of course. You can add a cache, or you can probably erase this. Okay, use an OpenAI embed call. That would be the simplest of approaches, but at least this was my approach. So thank you for watching, and in the part 2 we will probably discuss the implementation side of this, and I will show you all of this in code. Thank you.